Hello viewers, in our previous lectures we have discussed about maxima and minima. Viewers, we also discussed the first derivative test and the second derivative test. In this lecture we are going to take up some problems which are the direct application of maxima and minima. Clear? So let us take the first question. The first question is, find the maximum profit that a company can make if the profit function is given by p of x equal to minus 18x square plus 24x plus 41. Clear? Now here we see that we have to maximize the profit. Clear? And the profit function is a function of x. Clear? X may be the number of products which are produced by the company. Clear? Now we have to find the profit function, maximum profit from this profit function. So what we will do, we'll differentiate this function, that is we will find the derivative of p. Clear? So this is minus 36x plus 24. Clear? Now for the critical points, or we can write here for px to be maximum, the first derivative must be 0. Clear? So here we have minus 36x plus 24 equal to 0. Clear? So 36x is equal to 24. Clear? So here we have x equal to 24 over 36, which can be written as 2 by 3. So this is the turning point or the critical point. Clear? Now we'll find the second derivative of px. So the second derivative is from here we'll find the second derivative. This is minus 36. Clear? So here's it is obvious from this expression that the second derivative is less than 0, or the value of second derivative at x equal to 2 by 3 is minus 36, which is less than 0. So therefore x is equal to 2 by 3 is a point of maxima, Clear? So this is a point of maxima, and by second derivative test. So the maximum profit is calculated at x equal to 2 by 3. Clear? So this is the maximum profit. Okay, so here we have minus 18 multiplied, we will substitute 2 by 3 here. This is 24 times 2 by 3 plus 41. Clear? So here's this is minus 18 into 4 by 9, and here we have 3 8s are 8 2s are 16 plus 41. So this is 9 2s are, this is minus 8 plus this is 7, and this is 5. So here's this is 49. So this is the maximum profit made by the company. Clear? Now let us take the second question. Now viewers, here we have the problem, divide 8 into 2 positive parts. Clear? We have to divide 8 into 2 positive parts. So let us divide 8 into 2 parts, x and y. Clear? And such that x plus y is equal to 8. Such that the sum of the squares of square of one, say we take the square of x, and the cube of the other and the cube of the other means the cube of y. Say this quantity is say s. Clear? So divide 8 into two positive parts. Let the parts be x and y, such that the sum of the squares of one, that is one number, square of one number, and the cube of other number, and their sum is least. So s is least or minimum. Least or minimum. Clear? So here we have this equation and this equation. Now s is least or minimum. Now from 2 we have s equal to x square plus, now we from equation 1 we have y is equal to 8 minus x. So we substitute here, so we have 8 minus x cube. Clear? Now viewers, we see that this becomes a function of x. Now we differentiate equation 1, so we have ds over dx. So this is 2x, this is 3 times of 8 minus x square multiplied minus 1. Clear? Because the derivative of 8 minus x cube is, first we'll apply the formula for x raised to n. So we have 3 times 8 minus x square. Then by chain rule, 8 minus x, the derivative of 8 minus x is minus 1. Now we can write this equation as 2x plus, this can be written as minus 3, and this is 8 minus x square. Clear? This is equation number 3. Now for s to be least, the derivative s prime of x must be 0, or ds over dx must be 0. Clear? So we have 2x minus 3 times of 8 minus x square must be equal to 0. Clear? So from here we'll solve this equation. So this is 2x, this is minus 3, this is 64 plus x square minus 16x. Clear? So this can be written as 2x, this is 3 4s are 12, and this is 192 minus 3x square and plus 48x. Clear? So if we arrange this equation, we can write 3x square, and this is 48 plus 2, this is 50x, so we have minus 50x, and we have plus 192. Clear? Equal to 0. So here we have this quadratic equation. Now we have to solve this quadratic equation. Clear? Now we have this quadratic equation, and we can solve it by using quadratic formula, and so viewers, here we can find the discriminant, and the discriminant is b square minus 4ac, and we have minus 50 square minus 4 times of 3 times of 192, this is 2500 minus, and this is 2304, so we have 196. So the square root of this discriminant is plus minus square root of 196, this is plus minus 14. Clear? Now therefore x can be written as minus b plus minus square root of d over 2a. So x is minus b is minus 50 here, so minus b is 50 plus minus 14 here we have, and 2a is 3, So, and C is 192. So 3 3s are 2 3s are 6 here. Now if we take the positive sign, we have 64 over 6, and if we take the negative sign, we have 36 over 6. So we reject this one, because we have to divide 8 into 2 positive parts, and here this is a fraction, so we take this value, and this value is 6. Clear? So we'll take x is equal to 6. Clear? So here's if we get the value of x equal to 6, so therefore the critical point is x equal to 6. X equal to 6. Now we have to test that s is least, and by second derivative test we'll test by differentiating ds over dx. So the second derivative of s is 2, the derivative of 2x is 2, and here we have minus 3, then we have 2, 8 minus x, then minus 1. So this is 2 minus, this is minus and minus plus, so we have 3 2s are 6 times 8 minus x, this is 2 plus, this is 48 minus 6x, and we have 50 minus 6x. So if we substitute the value of x equal to 6 here, we see that, and this is 50 minus 6 6 are 36, and it is 14, which is greater than 0. So therefore the second derivative of s is greater than 0 at x equal to 6. Therefore s is least at x is equal to 6. Now we find the value of y. So if we put 6 here, we get 6 plus y is equal to 8, and y is equal to 2. So therefore the required two positive parts are 6 and 2. Clear? Now let us take the third problem. Now viewers, we have this problem. Find the largest possible area of a right angle triangle whose hypotenuse is 5 cm. So let us draw a right angle triangle here. Say this triangle is ABC, and this is 90 degree, and say this angle is, say, theta, and the hypotenuse is 5. Okay, and we have to find the largest possible area. It means we have to maximize the area function. Now let this side be x, and say this side be y centimeters. This is x centimeters, this is y centimeters. So the area function is here we can write simply the area, and we have area is half base into altitude, half base into altitude AB. So here's we write area is as half BC is y, and this is x. So we have half of xy. This is equation number 1. Now by Pythagoras theorem, because this is a right angle triangle and angle B is pi by 2, so therefore by making use of Pythagoras theorem here, we have AC square is equal to AB square plus BC square. Clear? So AC square is 5 square, AB square is x square, and BC is y square. So therefore x square plus y square is equal to 25. This is equation number 2. From here we can write y square is equal to 25 minus x square, or y can be written as square root of 25 minus x square. So say this equation is equation number 3. Now we substitute this value of y in equation 1. So therefore the area function becomes half of x times of square root of 25 minus x square. Now viewers, this becomes the area function, the function of x. Clear? So x is the perpendicular distance here. So now we have obtained the area function and we have to find the largest possible area. It means we have to maximize this area function ax, and for this we will have to differentiate this function. So viewers, let us differentiate it, but before differentiation I would like to tell you one more concept here. Since here we have the radical sign, so we can get rid of this radical sign by squaring both sides. So if I square both sides, we get 1 over 4 x square times 25 minus x square. Okay? Or we can write it like this, 1 by 4, this is 25 x square minus x raised to 4. Clear? Now viewers, always remember that if a is maximum or minimum, I am taking here both the conditions. If a is maximum or minimum, then a square should also be maximum or minimum. Clear? Now let a square be denoted by some other function, say p. Clear? So therefore p is 1 by 4 of 25 x square minus x raised to 4. Clear? Now in order to maximize this function ax, we will maximize p. Clear? Or px. This is p of x. Clear? So let us do it. So viewers, let us differentiate this function p. So dp over dx is equal to 1 by 4, this is 25x square, so this is 50x minus this is 4x cube. Clear? Say this equation is equation number 4. Clear? Now we'll put dp over dx is equal to 0 for a to be for the largest possible area. Clear? So we have 1 by 4 of 50x minus 4x cube equal to 0. So from here we get x 50 minus 4x square equal to 0. So we get x equal to 0 and 50 minus 4x square is equal to 0. So we reject this one because x equal to 0 is not possible here. So we reject it and we have 50 minus 4x square equal to 0, which is equal to 50 equal to 4x square, and x square can be written as 50 over 4, which is 25 by 2. So x is the positive sign of 25 by 2. Clear? Now this is the critical point or the turning point. Clear? Now we'll find the second derivative of p with respect to x square. I'm sorry, here this is we'll find the second derivative of p with respect to x. So this is 1 by 4 and this is 50x, so we have 50 minus, and this is 12x square. Clear? Now we substitute the value of x square equal to 25 by 2 here. So what we'll get? We'll get 1 by 4, 50 minus 12 multiplied 25 by 2. Okay? So this is 1 by 4, this is 50 minus 2 6s are, and 625s are is 150. Clear? So this is minus 100 over 4, which is minus 25, and which is less than 0. So therefore, by second derivative test, we see that p double prime of x is less than 0 at x equal to square root of 25 by 2. So at x equal to square root of 25 by 2, this area is maximum. Clear? Now to find the maximum area, first we'll find the value of y. So what is y? So therefore y is square root of 25 minus x square. This is 25, x square is 25 by 2. So this is 50 minus 25. This is again 25 by 2. Clear? So where's this is the value of y, this is the value of x. So therefore the maximum area is half base into altitude. So we have half of xy. So the maximum area is half times square root of 25 by 2 multiplied square root of 25 by 2. So we have half, we have 25 by 2. Clear? Here the multiplication of this quantity and this quantity is 25 by 2. So this is 25 by 4 square centimeters. Clear? So this is how we solve this problem. And see, this is a very conceptual problem here. Clear? Now let us solve another problem. Now viewers, we have this problem here. Find the point on the curve y square equal to 4x, which is nearest to the point. So nearest means minima. Clear? To the point 2 comma minus 8. So here's this represents our parabola, and this is it looks like this. Clear? So this passes through this origin, the vertex is at origin. So this is the curve y square is equal to 4x. Now we have to find a point on this curve which is nearest to this point 2 comma minus 8. So here's if I plot this point here, see this is 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6 7 8. So this is minus 8 here, and if I take here 1 2, so this point is, say this point is A, and this point is 2 comma minus 8. Clear? Now we have to, what is the meaning of this problem? The meaning of this problem is we have to search for a point on this curve, lying on this curve, which is nearest to this point. Now this point, we have located this point here. See, this is 1, this is 2, and here we have minus 1, and this is 0. This is minus 1, this is minus 2, minus 3, minus 4, 5, minus 6, minus 7, and this is minus 8. So this point is 2 comma minus 8, and we have to find a point on this curve. Say the point is here. Clear? Say this point is here. The required point is P, and say the coordinates of this point are a comma b. Now the distance between this point is nearest. Yeah, this is the nearest point. There may be points here, 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 or we can take points here, but all out of all those distances, this PA is the minimum distance. So we have to search for this point. What are the coordinates of this point P? Okay, so this is the meaning of this problem. So let us find, we have to find A and B. Clear? So let us solve it. Now the distance between the point P and A is calculated by using the distance formula, and viewers, we know that the distance formula between 2 points is given by this expression, x2 minus x1 square plus y2 minus y1 square. Clear? So the distance between, say, P and A is d. So what is d? So d is, let us for the simplicity, let us denote the distance between 2 points by say s. Clear? So s is the distance between P and A. Clear? So s is x2 minus x1, this is a minus 2 square plus b plus 8 square. Okay, or we can write s square is equal to a minus 2 square plus b plus 8 square. So whereas we have to minimize s. Clear? So this distance has to be minimized. We have to find the nearest point to this point so that this distance is minimum, and the distance between P and A is given by s. So we have to minimize s. Clear? Or s square. We have to minimize s or s square. Clear? Now let us denote, as we have done in our previous problem, let us denote s square by, say, p square, say p. Clear? So if s is minimum, then s square is minimum, and let us suppose s square equal to p. Clear? So therefore our p is a minus 2 square plus b plus 8 square. This is equation number 1. Now this point P lies on this parabola. Clear? So we have therefore we have b square is equal to 4 times of a, because a comma b lies on this curve. So this point must satisfy this equation. So b square is equal to 4a, or we can write a is equal to b square over 4, and let us substitute this value of a in this equation. So therefore p becomes b square minus b square over 4 minus 2 whole square plus b plus 8 square. Clear? So viewers, this is a function of b. Therefore the distance function between P and A is expressed in terms of b only. Clear? Okay, now let us differentiate this point, this expression P. So here's let us find dp over dx, dp over db, dp over db, because p is a function of b. Now the derivative of this term is 2 times of b square over 4 minus 2, then multiplied by 2b over 4, because by chain rule, plus the derivative of this function is 2 times of b plus 8 times 1, because the derivative of b is 1 and the derivative of 8 is 0. Similarly here we have 2 times, first we have applied this formula nx n minus 1, then we differentiated this term. So this is the derivative of b square is 2b divided by 4 here, and then the derivative of 2 is 0. So here 2 and this get cancelled, and we are left with this b is multiplied inside, so we have b cube over 4, this is minus 2b plus 2b, we multiplied these two terms by 2, and we have 2 8 just 16. So this 2b and this 2b get cancelled, and we are left with b cube over 4 plus 16. Clear? Now for critical points or turning points, we must have dp by db is equal to 0. Clear? Okay, now this dp over dv equal to 0 gives us b cube by 4 plus 16 is equal to 0. So b cube over 4 is equal to minus 16. B cube is minus 64. 4 16s are, and this can be written as minus 4 cube. So therefore b is equal to minus 4. Clear? Now let us differentiate this function here in order to verify whether b is a point of local minima or not. So we'll find d square p over db square. The second derivative test, we are applying second derivative test, so we must differentiate this function. So this is 3b square over 4, and the derivative of 16 is 0. So therefore the value of this second derivative at b equal to minus 4 is 3 by 4 times minus 4 square, and this is 3 by 4 times 16, this is 4 4s, this is 12, and this is greater than 0. So therefore we can say p is minimum at b is equal to minus 4. And what was p? P was our s square. So p is minimum, therefore s square is also minimum, and when s square is minimum, s is also minimum. Clear? Okay, so therefore we have b is equal to minus 4. Now we substitute this value here, so we get a, and a is minus 4 square over 4, and this is 16 over 4, and we have 4. So viewers, therefore the required coordinates of this point P are a comma b, and a is 4 and b is minus 4. So this is how we solve this problem. So viewers, let us take one more problem. Now viewers, we have one more important problem here, and we have to find the minimum value of this expression. We have to find the minimum value of this expression where we have we are given this condition. This is the condition. Clear? This is the condition. So let P is equal to this function ax plus by. Now we have to find the minimum value of this function, or we have to minimize P. We have to minimize P. Clear? So let us find it. So P can be written as ax plus b, and let us take the value of y from this expression. So y is c square over x. Clear? And substitute it here. So here we substitute c square over x. Clear? So here's let us write it in a simplified manner. This is ax plus this is bc over x. Clear? Now we have to find the derivative of p. So dp over dx is equal to, the derivative of x is 1 here, so we have a, and then we have bc square, and the derivative of 1 over x is minus 1 over x square. Clear? So this can be written as a minus bc square over x square. So this is equation number 1. Clear? Now for critical points, or for P to be minimum, we must have P prime of x should be 0. Here also we can see that this expression P is expressed as a function of x. Clear? So the derivative of p with respect to x must be 0, or dp over dx is equal to 0. These two are same thing. So here we have a minus bc square over x square must be equal to 0. So from here we have a is equal to bc square over x square. So x square is bc square over a. Clear? And x can be written as square root of bc square over a. Clear? Now viewers, let us find, this is the critical point. This is the critical point. Now we find the second derivative. So this is the second derivative of p. So we see that the derivative of a is 0 minus bc square, and the derivative of 1 over x square is minus 2 over x cube. Clear? So this is minus minus plus, this is 2 bc square over x cube. Clear? Now the value of the second derivative at this point is obviously positive. This is a positive quantity. This is a positive quantity. So or we can say that this is greater than 0, or we can write the value of second derivative at this point, that is square root of bc square over a, can be written as we can write 2bc square divided by x. So we have here bc square over a raised to 3 by 2, and obviously this quantity is greater than 0. So therefore P or ax plus by is minimum at this value of x. Clear? So if we take the positive value here, then the second derivative is greater than 0, and if we take the negative value of x, because this is square root of x, square root of this quantity bc square over a, so if we take x as positive, then the second derivative is greater than 0, so p is minimum. And when we take x negative value of x here, then obviously the second derivative will be less than 0 and p will be maximum. Clear? So therefore the minimum value of p occurs at when x is equal to plus bc square over a. Clear? So now let us so viewers, the minimum value of p occurs at x equal to plus square root of bc square over a, and the maximum value of p occurs at x equal to negative, which is minus bc square over a. Okay, so let us substitute x equal to plus square root of bc square over a in this expression here. Okay, therefore we'll find the value of this p at plus bc square over a. So this is the minimum value, and this is given by this expression. So we have a times, or we can write it, this expression can be written as ax square plus bc square over x. So we have a times, what is the value of x square? X square is bc square over a plus bc square and divided by square root of bc square over a. So whereas here we have a and a get cancelled, so we have bc square plus bc square 2bc square multiplied, we have a divided by bc square. Clear? Now we can simplify it further, or we can write it like this: 2bc square multiplied 1 over c divided by a over b. Clear? Or we can write it as 2bc multiplied a over b. Clear? So this is the required value, or this may be further simplified as 2 square root of a times c times square root of b. Clear? Or we can write 2c times of square root of ab. So this is the minimum value of this expression where xy is equal to c square. Clear?